Hello everybody, and welcome to the second webinar held together with the Low Carbon Building Technologies Gateway and Kickstart Online. So the second webinar is on integrating energy monitoring systems for smarter homes, and will be presented by myself, Dr. Elena Prokofyeva, John Stinson from Edinburgh Napier University, and Ken McCorkindale from UGCO. Just a few words for those who doesn't know or know little about Low Carbon Building Technologies Gateway. The project has started on 1st of July 2010, and it will run for 3 years and 4 months. So the project ends somewhere in October this year. So the outputs which are set for this project are quite large. So we're supposed to reach 1,000 organizations and create 20 supply chain partnerships, 40 research projects to be initiated, 300 products tested or reviewed for initial evaluation, and then the products animated and products put in onto the full-scale sites or innovation parks. So we work on expertise for acoustic structure, energy innovation design and sustainability. In total, by the end of 2012, we reached 260 products on assessments and tests, and we also, that's approximately 87% of the project completed. The project is assessing products through two phases. Phase 1 related to the testing of prototypes and assessment, and phase 2 is related to installation of the real houses. So the project we will be talking about today is on energy, and it is actually came through both stages eventually, from phase 1 and phase 2, and has been installed in different locations. So now I am giving the control to Ken McCorkindale of UGCO, and he will talk to you about the company and then about the project.
Thanks, Elena. You clicked on. So just a brief introduction to our company UGCO and the product, and then John will explain how we work together on the project. And what I want to talk about really is that, the focus of our company is about how we use design and technology to affect behavioural change in energy consumers. And I just thought this image was quite pertinent because when we started the company around 6 years ago, energy waste and the whole question of the environment, etc., was quite prominent in the media, and it kind of disappeared for a few years while we all took cover from the economic crisis. But recently, again, it has been headline news because, of course, we're facing the prospect of running out of power and power stations having to close down faster than we can replace them, etc. So it's a subject which is obviously very dear to our hearts, and I think becoming much more important again to end users. So the product, we started the company about 6 years ago, and we were the first multi-channel real-time display device for electricity, water, gas, and since then we added heat and renewables, and we can connect to a number of different types of data. We connect to legacy type meters via pulses, and we use CTs to connect onto electricity. The whole focus of the product really is to give an intuitive and simple and easy to understand interface, which requires minimal effort to understand. We wanted to present information to consumers in a way that was very easy to access, and so we decided to use colour and a very simple traffic light system because those are things that are universally understood. And at the time when we first developed this product, we didn't have smartphones. The first iPhone was launched in November 2007. And of course, consumer expectations have changed since then, and we're now trying to keep up with those. So most people still don't really understand how their behaviour impacts energy spend. And it's really not so much to do with the information that you give to end users, it's more to do with the way that you actually give them it and how you display information. If you can display it in a way which is engaging and easy to understand, then it's much more likely that people will actually take interest in it and potentially change behaviour. Our product goes into both domestic and non-domestic settings. I suppose, value proposition is similar. It's to do with engaging people with how their behaviour has a direct effect on how much energy they consume, and if people are aware of how their actions affect the use and waste of energy, then they're much more likely to feel that they can take some sort of control of that and effect change to reduce wastage. So we push information to end users, as I've said, they're occupants. And I think that's quite an important distinction between what our product does and what some purely online services do. We think there is always a case, there is always a place for actually pushing that information to people in homes and in buildings, rather than expecting them to go and find it. Regardless of how interactive and engaging a web service might be, somebody still has to make the decision that they want to go and find that information. And what our product does is it sticks on the wall all the time, 24 hours a day, and it pushes that at-a-glance information so people are constantly aware of what's going on. And this is just really to reinforce the fact that although the product is relatively small, even when we have it in very large office environments, staff notice it because they walk by it on a day-to-day basis, exactly the same as what happens in people's homes. And if we can engage with people in their homes and in their office spaces, then they're likely to take the behaviour that they have at work back home and vice versa. So together with our piece of hardware, which is, or pieces of hardware, which is the sensors that collect the data and the displays which push that data locally within environments, we also have a web-based service which collects all that data and provides it back to end users via a very intuitive analytics package, I suppose, that enables people really just to drill down into their usage patterns, set themselves targets, thresholds, etc. And I'll pass over to John.
Thanks, Ken. I'm just going to talk a little bit now about a collaborative project between Edinburgh Napier and UGECO. So this portion of the slides is going to be using the case study of the project that we were engaged with to talk about what we set out to find, what we did find, and how that relates in a wider scope. Okay, so just to frame it slightly, a lot of the work that we do currently at the Scottish Energy Centre within Edinburgh Napier focuses on looking at fabric first and thermal upgrades of properties, doing building performance evaluation, post-occupancy evaluation, etc., assessment of the building envelope and comparison to predicted design of a property and then how it performs in reality. A second part of the wing at the Scottish Energy Centre looks at the performance of micro-renewables, on-site heat generation and power generation. And for those who are in similar fields as what we do, looking at how buildings are designed to perform and how they actually perform starts to raise this very poignant question as to how the actors inside these homes that we're placing them into, how they're responding to these new, more advanced homes. So this kind of led a research path looking at reducing energy within the home, fabric first approach, looking at renewables, but also the consumer engagement and how the end user thinks, treats, and understands energy, their attitudes, lifestyles, and kind of habits towards that. So this led towards our Smarter Homes investigation. To frame this slightly differently, these are the three pillars really looking towards moving towards a low carbon home. So we have the thermal envelope being improved, and that's being that's being regulated, and through legislation, through building regulations, and through incentives, and all through building performance and building assessment software at the design stage, looking at eco homes or Section 7 to encourage designers to improve building stock and the future of the building stock. The micro-renewables are incentivised through numerous different government incentivisation schemes, the feed-in tariff for power and the renewable heat incentive coming out later on, being regenerated later on this year. And that's the regulated energy, which we all know and works in how the house is designed to be performed, or designed to perform. The other aspect of this is the unregulated energy use. And through, as I said before, through our work with building performance evaluation, the fabric tends to stand up pretty close, if not within a certain margin of how we expect it to perform. But when we start looking at the energy consumption of these homes a year or 2 years later, and we start to see how they're drastically different from what we expected, that's where we needed to understand. And there's been a very good webinar recently on Kickstart, the Kickstart series of webinars from Julio Bross Williamson and Dr. Purdy of the Morrison Partnership, which looks specifically at the performance gap. We're looking here at the knowledge gap, which is a term coined focusing on how people understand to use their homes and then how they actually use them in reality. So categorising the changing energy use behaviour extends to instigating habitual energy conservation behaviour, and then prioritising these decision-making procedures within the occupants to creating energy efficient behaviour much higher up on their list of priorities, decision-making, and changing how they view the purchasing of energy as well. And this extends then to reducing the amount of energy they don't need to have on, so reducing wasted energy, and then creating more of a greater social sphere, having a greater social relevance within smaller communities and local communities, etc. So I was going to talk a little bit now specifically about the project that we were able to be involved in. The Low Carbon Building Technology Gateway funded a large part of the project the first couple of months leading up to the field work, and the Technology Strategy Board released a call, and we were able to successfully secure funding for that and do 8 months of field trials. And we were able to involve 2 housing associations, which allowed us access to their stock. So these were houses and flats that were being built in the summer, and the UGECO Energy Monitor was specifically specified for these homes. So before anyone had moved in, the research team had allocated, with the help of the housing officers, a portion of occupants. All the homes were going to have energy monitors, but a portion of the occupants were going to have the energy monitor concealed somewhere on site. So for all intents and purposes, they didn't have any energy monitor, where a similar sample of people had this energy monitor on display. Side-by-side comparative data analysis, and this also included a qualitative data collection aspect to it. So we had the energy monitor that was going to do the data logging and the monitoring, the tracking, but we also went in at the very beginning of the project with questionnaire structure interviews, spoke with the entire family and the inhabitants of that home, baselined and profiled the occupants, and we asked questions relating to how they use energy, related to how they heat their homes and use hot water, and the amount of appliances they have and their daily routines, etc. So this created a backstop of how, if their behaviour is going to change, by the end of the project, re-ask these questions again so we can start to quantify it that way. I included this slide just recently because I think it kind of contextualised it for those who see projects like this and want to extrapolate it up in a certain degree. As I said, this was social housing properties. There's 52 of them, and just looking at the figures, it's a fairly important part of the housing stock in Scotland. I also just come across this graph fairly recently. It was done by the Scottish House Condition Survey, and it was produced recently, but it was data collected during the year whenever we were doing our field study. And what kind of jumped out at me, and the reason why I included here on this is not our figures. This is the Scottish House Condition Survey figures. But let's see, get a little cursor on here. There we go. There we go. So we have, at this end of the scale, we have the income band per week charged against how often people look at these energy monitors. And for those who have ever been involved with a Scottish House Condition Survey or have seen the work or looked at methodology, there's a question now creeping in which is asked how many people have these energy monitors, and that figure is increasing each time this work's being undertaken. But a second part of that question asks about how often people view and engage with these energy monitors on the whole. And what stood out to me here was we start to have a gradient based on the per week income. And what I've noticed, just very, very loosely here, is we tend to have quite a large portion of people who engage with energy monitor more passively in the higher end of the income. And I can almost say categorically that our occupants fell within this band of income here for our particular study, and it's almost fallen into the greater portion of these results. People who engage with these energy monitors it's almost polarised, either very closely or almost not at all. And for me, it's almost like an educational deficit where people who don't see the relevance at one end of the scale, or there's people in the same income group see extreme relevance in this. So I thought that was a quite interesting one. So back to the study. Before we kicked off the project, or after the first questionnaires, after the very initial stage of the project, we were looking to categorise the barriers and challenges that we may foresee in this project, and certainly this is what similar projects had pulled up during their work. I'm not going to go through them all, but a number of them here that I want to kind of point out is the invisible energy. People actually are removed from turning fairly guilty in the way that we use energy as a society, and I think it comes back to how each of these occupants had grown up through their lifestyle and through their family dynamic previously before entering to this home. And certainly a lot of the decisions they make is based on homes they've had before or experiences they've had before and how successful they were on implementing previous energy behaviour changing styles and lifestyles. The other one here is good intentions, and what I would say from the very beginning is that from the outset of all the people involved in the trial, for those who had the energy monitor and those who didn't, it was high up on their priority to want to change. But as for the path of how to change that, and as for the path of how to make the significant changes and make those prolonged changes, it didn't always come through in the discussions on how they could enable that and keep that persistent. So the good intentions were always there. It's just about realising that and making it practical. The family dynamic, I'm going to come on to that a little bit later on, but what I'll say at this point is that a lot of the energy reduction strategies are geared towards the bill payer, and it's not just that person who's operating this environment. This environment, it's fairly dynamic and organic in the way it's being used and how it's been seen by various different members of the family. So we're looking at properties here with 2, 3, 4, and up to even 5 occupants. 3 or 4 of them being students or being children at a certain age, and they're going to be using energy, but not always receiving this level of information on how to change it. I'll come back to that a bit later. But then this last part in this slide here is just removed from the purchasing, and many analogies have been used before in this instance where you wouldn't go around Tesco's or Asda or any sort of shopping centre and start purchasing stuff out seeing the price. It's just not the way we purchase other things, so why should we purchase energy in this way? So very simply, just going to show this diagram, and this was the environment in which that we were going to enter into with occupants who either come from homes similar to this kind of existing mechanism or what they expected to move into. So this is the cycle that people are expected to start to bring on pro-energy efficient behaviour. So you use the energy in the home, the energy is tallied 30 to 90 days later and comes back. And that's when then the occupant gets the first glance of how they performed or how they're using the month before, or 3 months before. So this environment here is not conducive of a very cognitive learning experience. It's very reactive. And certainly in our study, the people who have made comment on getting bills previously and initially have that initial shock factor and go, okay, that was too high that month, need to break it down. But essentially that shock factor kind of wears off after a number of days because routines and priorities and other things become more significant. This is what we proposed, and this is what we installed as a model going forward in that project, where we had an instantaneous feedback loop. So we weren't improving on the existing loop. We weren't going to influence their bills or how the bills were described or how they were broken down or how they were graphically formatted. It was this instantaneous feedback internally. So the energy was used. The energy was used inside the home. It was gathered by this energy monitor and was reported back to them in real time. And that was to create this cognitive learning environment and a display format so everyone in the home could see this and how it was being used. So we chose the UGECO Energy Monitor, Scottish SME, and we were involved with Ken McCorkindale and Tanya Ewing long before this project had surfaced. But this energy monitor provided exactly what we were looking for from a logging perspective, where it was able to both gather, collect, record and show the information relating to electricity and gas. So it was a whole house, whole home energy consumption display unit. It was also self-calibrating, which meant that it was in home for the first week and then it was able to categorize or create limits on the coloured bars like you saw on some of Ken's images previously. Because it was colour, because it was vivid, it was different from other energy monitors that was used in other trials. So it did have a numerical display, but that wasn't the largest part of the display. It was this coloured, traffic coloured portion of the monitor that Ken's spoken about, which is used in other aspects of our day-to-day life, from traffic lights, and just using the very basic colour, the colour recognition of human understanding. Red is bad and green is good, and we've been conditioned to see those colours meaning those things. So this energy monitor really had the unique factor, and it also had the logging capacity. So I'm going to quickly move on to the results just now. This is the total consumption results over the 6 month period, and what I would say here is just worth mentioning is it was across one of the coldest winters we had seen for quite some time. And what we have charted here is the properties without the energy monitor, or with them concealed in the red solid line here, and those with the energy monitor on display is the dashed blue line below. So the headline result here is that those with the energy with UGECO used 20% less gas than those without it. And just coming back to the qualitative questionnaires, this result also was statistically significant as behaviour change. And I think it's important to mention that, as I said before, all the occupants were profiled on how they understand and use gas for their heating and water heating. And at the start of the trial, all the occupants in both samples, those with UGECO and those without it, answered the questions very similarly. And it comes down to they used the heating when they wanted it. There was no use of controls. Very few of them understood what a TRV was, and no one engaged with the thermostats at any part of the system. 6 months down the line, we returned same questionnaires, and those with the energy monitor changed how they answered, how they responded to those questions significantly, to the point where they engaged with the thermostats, they engaged with the temperature controls, and they also started to zone different parts of the house, so they were using heating more efficiently, and they were using the timer as well, whereas those without the energy monitor continued to use gas in exactly the same way. And what I think is significant here, and because other energy monitoring trials in the past, especially in the UK, never focused on the gas consumption aspect up until this trial. And I found this just recently. It was just published recently from DEC, but it was also done for the period of time whenever our research is being undertaken. And obviously, Scotland is up there as the average domestic gas consumption per consumer, because it's colder than some of these other areas here in the UK. But it does make it significant whenever you start to look at how much was saved in this trial simply through the engagement of the users to this energy monitor. These are the results for the electricity aspect of it. And what I would say, really coming back and just relying back on our qualitative results, were the occupants in both samples were fairly confident in how they seen the use of electricity and their strategies and behaviour towards saving electricity and reducing the electricity needed to use. But what is important here is that the energy monitor, for those who were using it, was seen for its advantages as a budgeting tool. An example I would use here is that the occupants in these homes, some of the occupants in these homes were struggling at a certain point during the trial to keep an eye on how much money they were using, how much money they were spending on electricity. So a lot of them then opted for the utility company to come in and put in this prepaid meter, which they had commented was one of the most significant ways and most beneficial ways on keeping an eye on their outgoings for that particular utility. Whereas those with the energy monitor who said they would have changed actually said that the GECO was being used for its budgeting tool and was able to be more proactive and keep an eye on how much they were using before they got to their limit, and then they would instinctively turn off electricity rather than having it turned off on them. So that was very significant there. And also the aspect of the energy monitor being used as a safety precaution function. Those specifically electricity were able to say and comment during the interviews that they begin to rely on this device and glancing at it before they left the home or before they went to bed to make sure all the things were turned off. And that you weren't getting that sort of feedback from those without the energy monitor. They've seen budgeting and controlling their house slightly differently. So, just moving on quickly to the qualitative feedback, more specifically for this project, 94% said that GECO made them more aware of how much energy they were using. 80% stated that the GECO increased their awareness of how much money they were spending on energy, and 91% of the occupants said that the GECO energy monitor was easy to use. And this is just testament to how it was designed, the intuitive colour display, and the different parts of the monitor, which allows specific use of colour at a glance or number for budgeting. 73% felt that the GECO made them reduce the amount of energy they used. What I would say here is, and I think it's worth mentioning, is that during the interviews and questionnaires, there's a bit of a disconnect between people seeing them using the energy monitor and actually then reporting that they used the energy monitor. And an example I would give here is one of the parts of the questions in the questionnaire was, do you use the energy monitor? And one or two of the occupants would come back and say, no, I don't use it. And then they would continue on by saying, all I do is, when it's in the red, I make sure things are turned off, and when it's in the green, I know I can actually start using things. And that's actually the key part of using the energy monitor. So they didn't actually relate that behaviour to using the energy monitor. So I think that's the reason why that number is there. And I would say after the first three or 4 month period, the GECO energy monitor had taken almost like a different role within the learning environment or within the household energy consumption environment. The first couple of weeks or months in some instances, it was being engaged with quite heavily, and people were using the full array of different GECO functions on there. And that was to try and understand what different parts of the home were using at different times of the day, and also different appliances. So it was giving them the ability to start to understand how then to use these appliances for the future. certainly these homes, and I would say it probably extend to many other homes, our equipment doesn't change very often, and especially those related to how the house is run. So washing machines, tumble dryers, and equipment, fridges and freezers, which can use quite a significant amount of energy, they change very rarely. So whenever they understand how these things operate and how much they use, they can be used more efficiently or used on a time of day that is more relevant to the occupant. 84% said that they minimised the energy they used because it saved money. 53 said because it was good for the environment. I just put that in there because it was just, I thought it was relevant to say that the tariff aspect of the energy monitor was very highly reported as a function which allowed them to understand their bills and how they understood purchasing of energy. Come on to that in a few minutes. Many of the participants with UGECO profess that they become increasingly confident about their utility bills. And I think this is also important because on the lead up to the project and the first set of questionnaires, etc., people were completely demystified with these energy bills, and I was actually being shown by a number of the occupants lumps of unopened utility bills because either they didn't want to know, they didn't know, or they didn't think they could understand. But that was a fairly important way for them to start to understand how much they were using on a monthly or bi-monthly or quarterly basis. And after the use of the energy monitor, which broke it down, the tariff and the kilowatt hour, etc., and that aspect of it, a lot of them then started to open the bills and understand the bills, and a few of them then went one step further and then contacted the utility company to change the tariff. All the occupants wanted the device to remain in the property at the end of the trial, which is good because it was theirs. But what I would say here is people had the energy monitor had become ingrained in their lifestyle. It was now a part of from those people who say, I use this thing religiously, I use all the different functions, to people who say, I just glance at it across the room. All the people right down that spectrum said that it was important for them for this to remain in their home because they wouldn't know how to keep this behaviour ongoing and persist with the new habitual routine if it was to leave the property. Key outcomes, the real-time, some of the things that were specifically and repeatedly commented on by the occupants at the end of the trial, those who had the energy monitor, was it closed the link between action and consequence. So whenever something was being turned on or left on or being on for too long, then they're able to initially address that, and that closed that loop of action and consequence, or made that loop tighter, sorry. Because it was a whole house energy monitor, they were able to see both electricity and gas, and that was very important because coming back to the results, people in this particular trial had specifically said that, and some of the anecdotal evidence coming out said that because they were quite confident in understanding how to reduce the amount of electricity because it was ingrained with them in their previous and whenever they were children in their family growing up, and more than enough of the comments I come back at the parents or the grandparents were screaming and shouting at them because they were leaving the lights on for too long. But it was never those stories never related to heating. It was always just electricity. So I think that's the reason why we saw such a significant result for the gas consumption change, was for a large portion, for the first time, people were able to see in real time the energy consumption of their gas behaviour and able to create new behaviours and new habits and different lifestyles. Simplified colour display, that was mentioned repeatedly, and the knowledge transfer, and that relates more to how the information trickled between each member of the family. Observations on the user interaction. The energy monitor had brought forward change that participants had planned to make, so that comes back to my earlier comment on good intentions. Initiated change where the possibility had not occurred. I think this comes back again to the gas usage. So as I said before, at the initial stages of the work, a lot of people had said that we just use gas the way we want to use it, we just turn the heating on and turn it off. There's no way I can improve my gas consumption. What it is what it is. And then going down the line, 6 months later, they were impressed about just how much simple changes in attitude, and having that feedback loop where you have the thermostat at 25 degrees, you turn that down to 18 degrees, and you see the coloured bars moving responsive to that, and it creates that self-efficacy, it creates that feel-good factor, and that's what keeps intentions ingrained. I'm going to come on to that in a moment. Whole house learning, cognitive learning experience. What we benefited from here, and because we conducted interviews not just with the bill payer, but we conducted interviews with the whole family. So we were sitting down with parents and children different age, and those who could participate in the questionnaires and the interviews did, and it was extremely interesting and quite reassuring to see that children at 6, 7, 8, 9 years old were able to describe to me how this energy monitor works. We're able to then use the information they get and explain that to, a lot of them are using this for projects in school, and then for the work that UGECA were doing with the schools in Perth, many of these schools, primary schools, had these UGECAs installed, and that, as Ken had spoken about how the different actors in the domestic move into non-domestic, the environment change if the person doesn't. Same with the children growing up, they're in the home, they're learning about using energy, they're not connected to how it's been paid, but indirectly they're influenced by how much money then the bill payer or the parent has to spend on other things, so it indirectly impacts on them. And then having that systematic, having that parallel learning experience in the school kind of brought this closer to home and made this learning environment much more richer. Moving on, increased learning of operating the home, appliances left on too long, I mentioned that earlier, and confidence with utility bills and jargon, coming back to kilowatt hour and the CO2 function as well. So this is what we know. The intention to reduce energy is reduce the consumptions there, because the occupants want to spend money on things that they find relevant for their quality of life, and they find relevant that they want to spend things on that they can say, well, okay, I'm going to buy something which means something to them, and not just going out to the utilities. The intention is there not to be in this fuel poor bracket, and for many it's a sense of pride not being fuel poor, and don't want to have to be just another figure in a statistic, etc., and all those sort of things relate to that. So intentions are there, and the route to behaviour change is creating habit, and to repeat habit. So we know that the intention to change can be brought forward to the improvement of energy literacy and knowledge of behaviour, and by installing the belief that change is a good thing. So by creating this environment where the energy monitor is put in place and people can learn from what they're doing instantaneously, then that feeds back into their intention to want to change, and if that intention is made repeatedly, it comes in a habit becomes ingrained, goes into behaviour, and it's now a lifestyle part. This is the last slide before I move back over to Ken. But what we want to see moving forward now, and through more funding and more support and help through the gateway, is going back to this particular project 18 months down the line, and just seeing exactly how things have changed and how consumption may have changed, and how people's and if we did step persistence effect, if there was a rebound effect, or we can begin to learn from these things being in place for longer. And also we want to start to understand controls inside the home. And I'm going to pass over to Ken before I talk too much about this, but the energy monitor is ideally placed within because it's the hub of the home, and it's recording consumption, but it's also in a particular important position within that gap between what's being used and the consumer, and creating this level of control, either high level control or low level control, you can start to see baseline energy consumption reduce, maybe peak load shifting, etc. So on that note, I'm going to pass over to Ken.
Thanks, John. Can I just nudge that round a wee bit?
Yeah.
So I just wanted to start by kind of reinforcing this message. John's already delivered it quite well, that well-designed displays do deliver savings. So we've seen that working with Napier University, the study showed that we can save 20% on average, over 20% average, so we had 20% on gas and more than 7% on electricity. in that particular study, and we've seen similar type results in other studies that we've done and in various types of installations, both domestic and non-domestic. Another interesting study which was done that was a lot bigger, that focused on smart meters and displays that were delivered with various smart meter programs globally, published by VASA ETT. It was commissioned by ESMIG over a year ago now, showed that where smart meters were installed with in-home displays, they saw an average of 8.7% reduction in energy consumption, which again is a lot bigger than the kind of numbers that we had been given by the UK government, actually, following the EDRP projects that were undertaken a couple of years ago, where utility companies rolled out what we term as CERT type displays. That's the consumer energy reduction target. And those displays were rolled out by energy companies to hundreds of thousands, millions of users around the country. But unfortunately, the sort of price point that was that worked in order for that project to work was relatively low, and it meant that a lot of the displays that went out were, by their very nature, relatively kind of low technology, and it meant that they were less engaging for end users. And of course the result was that we saw relatively poor results in terms of potential energy being saved, because people just were not engaging with them very well. The smart meter rollout, which is due to initiate towards the end of next year, the whole business case for that relies upon consumers changing behaviour, and they're supposed to change behaviour because they're engaging with how they use energy a little bit better, and the mechanism for them doing that is through consumer devices which will be connected to the smart meters in their homes, so in-home displays and what we call consumer access devices, which are other devices that will be able to take smart meter data and hopefully use that in a clever way within domestic households to engage people better, perhaps give them more control as well. This is just a little bit of showing off. Actually, UGECO has been recognised many times for its efforts in terms of design and engaging end users, and this is an award that we won recently in Scotland. So what's quite interesting is that, as John said, since we did the study with Napier, of course technology has been moving forward apace in parallel to that, and we as a company have been looking at what we can do with new technology that becomes available. And so we have been developing our next generation displays. Better technology is available, so we now have larger touchscreen type displays at a more affordable price. Those of course can be full colour, much more interactive, more engaging, and that offers us a lot of possibilities in terms of designing more engaging user interfaces. So this is just an image of one of our new displays. One of the things that we found when we came to redesigning our displays was that although technology has moved on, etc., the basic principle of keeping it very simple in order for people to be able to engage with this information at a distance doesn't change at all. And so the traffic light display is something that we saw as being very effective and continues to be really engaging, and so we're retaining that in our new displays. We're able to make it a little bit more intuitive, put the actual figure of how much you're consuming within that top red bar you see on the image there, and that helps to get the instant message across even faster. But we can also look at using graphic user interfaces in a little bit more of a kind of imaginative way, such that we can try to deliver what is sometimes quite complicated information, such as what is your profile today so far, and should you be worried about it? And if you can use something like the mechanism we have in the top right there, such as a clock that has a little segmented display around the edge that shows you when you've been in the green and when you've been in the orange and red, that's the kind of high-level information which, if you feed it back to end users in a graphic, engaging way, they will take note of it. And it's high enough level that they're able to absorb it quickly and hopefully make sense of it and change the behaviour if necessary. So, in line with things like display technology changing and more affordable bits of electronics kit being available to us now, consumers' expectations are also changing rapidly and have changed dramatically in the last 5-6 years with the advent of smartphones and mobile tablet type devices. We now find that consumers expect to be able to receive all sorts and pretty much any kind of information via these familiar devices. And so we need to respond to that, and it's a huge opportunity for our industry and for everyone involved in energy. It's a huge opportunity to be able to better communicate with end users and to really engage with them and deliver better information back to them so they can make decisions in shorter spaces of time to affect good energy management. And this is an example of actually a fitness. Essentially, it's a web service. It's a web mobile device service called Endomondo, and you can access certain information on your phone whilst you're on the move, cycling or running. You can then also look at how you've performed via your web service once you're off your bike and you're sitting down at home, comfortable in front of your PC. You can share that information with your pals or with your family, etc. And that kind of behaviour is becoming expected and very common amongst domestic consumers. So if we can look to develop energy services around a similar type pattern, it's likely that consumers will engage with that. And as I've said there, I want information and advice on my preferred interface. People respond very, very well to our local displays on the wall, pushing information. But what consumers increasingly are looking for is that they want all and any sort of information to be delivered to them via this device in their pocket. We don't believe that it replaces the value of the display on the wall. There is always a need for this constant at-a-glance information that you don't have to go and look for yourself. But if we can look to be using the opportunities that we now have available via these mobile devices, we can create a much more kind of holistic approach to engaging users. So you get the right information at the right time to help me make the right decisions. So how are we applying that, and also other people in our industry? We're looking at how we can develop the web service aspect of what we do. Users tend to behave differently when they're looking at a web service on a PC to when they're looking at something on their mobile phone. Typically, people will sit in front of a PC, they're sitting down, they spend a bit more time, they're more interested in analysis, they're more interested in a bit of detail. Whereas when they pick up their mobile device, they want instant gratification almost. They spend a few seconds looking at the thing, they're on the move. And the example on the right there, which I'll get onto in a second, is that we're now looking at being able to install technology in people's homes which enables us to gather data and deliver it back to the end user. Gather it, analyze it, deliver it back to the end user in a relevant and timely fashion, such that you can then also provide the end user with a level of control which responds to the information that you've given them, such as, it's 26 degrees in here and you're currently spending £1.60 on your heating. Would you like to turn it down in order to save some money? And the idea here is that you can just very simply use your finger to turn down the dial and see the money going down as you do it. That's the kind of closing the loop which will become available to us overcoming, sort of the next 18 months. So something that we hear a lot about is big data, and of course our consumption patterns and data about how we consume various things is being collected all over the place without us even knowing it. And the question here is, does more data mean more engagement and more behaviour change? And not necessarily, but if we're clever about it, then it certainly could lead us that way. Some key things that we need to remember are that it's very important to get inside the psychology of end users, people within domestic settings, and understand what actually motivates them to behave, to change their behaviour. Different kinds of people have different motivations. Some people are interested in saving money. Some people are interested in doing what's right for the environment. Other people just have an inbuilt nature. I think John mentioned that they've been brought up not to waste. And so if we can get a good understanding of what motivates different types of end users, then we will be in a much better position to be able to deliver services that are relevant to them. Timing is very important. We need to figure out when users are most receptive to messages. It's pointless sending somebody a message at 3 o'clock in the morning if he's going to be asleep. We need to be trying to deliver information to end users at the point where they are making a decision. So, if they're about to leave home and they've left all their lights on and the heating is going to be on for the next 6 hours, can we communicate with them at that point in order to give them a friendly reminder that there might be an opportunity to switch some stuff off and save energy? And we need to build a relationship with the people who are using these devices and services. People need to feel that they can trust the service, and one of the reasons that our product, the product that was used in the studies, has been so successful is that people do learn to trust it. It's a very, very simple message that it's delivering, and people start to treat it as a fabric of their home and a part of their day-to-day life. There's a trust between the consumer and the object, and that's a very, very important thing in making sure that we're delivering services that help people understand how they can influence energy consumption. Again, designed to respond to the motivations that different people have for changing behaviour. So we're looking at how does that help us to better design energy management solutions. We want to understand what makes people in domestic environments change behaviour, use energy data to deliver targeted and timely messages, and incentivise them to care and take action. The link that I've got there actually won't work at the moment. If you are interested in looking it up, it's a little video totally unrelated to energy. It's some stuff that Volkswagen did a few years ago, which I find really interesting. And there's a great video of how they took a set of stairs that go into an underground and looked at how they could make people take the stairs rather than the escalator. And what they did was they turned the stairs into a piano, so that as you walk up and down the stairs, it makes noise. It makes the sound of a piano. And 66% of people changed their behaviour and went up and down the piano stairs instead of the escalator. It's a funny little example of how you can use different ways of engaging with people to get them to change behaviour. This image again, people are very busy. This guy's not particularly busy, but he probably thinks that he is, and he doesn't want to have another gadget in his home. And okay, you're telling me I'm using too much, but what should I do about it? People change behaviour when they're engaged and incentivized, and the reasons that people change behaviour are many and various. And some of the key ones are comfort, convenience, control, money, fun, and fear. And if we can tap into what makes different people change their behaviour and deliver solutions that respond to that, then we stand a chance of being successful. So making energy information relevant is the key, really. There have been various studies done, and some other companies and organisations are beginning to look at this with some success. That people are influenced by their social network. And so showing energy usage and behaviour in the context of their peers, neighbours and family helps make it a subject they engage with. Similarly in the work environment, how does my energy use compare with colleagues, other offices or teams? And often when people are shown how they, if my house is kind of down in the lower quarter of energy consumers, in terms of me being much more wasteful than my neighbours, that kind of message is often enough to incentivize people to want to change. So this is an example actually of something that O-Power does. O-Power have looked at how they can use enormous amounts of data collected from hundreds of thousands of domestic consumers, and use that to create profiles that help them to target end users with relevant and timely information. And they have successfully shown that when they deliver a sort of neighbour comparison, it helps people to understand how they stack up, and it does have the effect of making them change their behaviour. And we also then have opportunities to share information, create common goals with communities, families, etc. And all of that, I think, is a great opportunity for us as an industry to better engage with people and help them to feel incentivised to change their behaviour. So what if we could send information to consumers about their behaviour in almost real time? We need quite a lot of stuff going on in the background. We need sensors in people's homes to collect lots of different data. We need a means of sending it all to a central location. We need data analytics to make sense of it. We need algorithms to change the data into meaningful communications to send back to targeted users. We need user interfaces to deliver messages in a compelling and engaging way. We need controls to enable user choices to be instantly turned into actions that reduce energy wastage. And then we need, at the end of that, feedback to tell the user that he's made a change and it's had a positive effect. If we could deliver all of that, then we really will have almost a kind of closed loop system that gives the users the information and control that they're looking for. Some of that is likely to become available when smart meters are rolled out. We as a company are looking at how we can deliver aspects of that technology. And our new platform is called NetThings. NetThings is to do with much more than just collecting information and displaying it via a local display. We're looking at, on the left-hand side of this image, at being able to collect data from a much wider range of sources. So as well as meter data, we can be looking at information from renewable sources, heat meters, smart meters. We can be measuring real power by measuring the voltage as well. We can help to optimize power signatures, so we can recognize individual appliances, etc., as well as temperature and humidity and CO2. And if we can collect all that information, then we are in a position to be able to analyze that and look at how the different types of information interact with each other and feed it back. The secret is in then processing all of that to feed it back to end users in a way that makes sense to them. It's pointless just to deliver thousands of bits of data on a spreadsheet. Nobody's interested in it. And so the key then is that we have a central hub device, which in a home might be a consumer access device in the terminology of smart metering. That can deliver information to a local display. It can also send data back up to the web, where we have a web service called MyUGICO. And that is where we're then providing information via a number of different user interfaces on the right-hand side. And it's really, what user interface do you prefer as a consumer? Do you can have the local display in your home, and that will deliver simple, easy to understand, engaging information. However, we know that you also want to get information via your mobile, your laptop, your PC, etc. And critically, if we can then provide messages and options back to end users, so collect the data, process it, give it back to end users, and give them some control so that they can then, the flick of a switch or the press of a button on their mobile phone, they can actually change some of the energy using patterns within their home without having to get up and go and look for it themselves. You know, that's when it becomes really, really interesting to end users, and they're more likely to actually engage with it as well. And that's what the control aspect is at the bottom of the page there. So our system is able to collect data, deliver it back to end users, and also control devices within the home. And this image really just illustrates that that kind of platform has lots of different potential applications. So we're also working with business customers to change behaviour, and different people in the organisation respond to different sorts of information. And I'm showing this because what we're learning from doing some pilot work with some of our non-domestic customers is very relevant in how we then look at what works with domestic customers. And this is an example of a tailored report. We actually are calling this our Virtual Energy Manager service, and it's where we're looking at delivering key bits of information back to certain key people within an organisation in a way which is easily digestible to them and that they can then act upon, or that they can then use to go and use as a little bit of a carrot and a stick with some of their colleagues to get them to change behaviour. And one of the, we're using this the sort of green, orange, red bars idea on the right hand side. So in this case, you're down 7% on the previous period, and that's great, well done. But delivering this monetary information in a way that actually makes sense to the particular business. So rather than just saying your average the last 4 weeks is £205 spent on electricity, and last week it was £185, deliver it in a currency that makes sense to them. So in the last 4 weeks you had to sell on average 29 printer cartridges to pay for your electricity, and last week you only had to sell 22. So it's delivering it in a currency in a way that makes sense to the bottom line of the business. And we found that actually is a very simple mechanism, but it works very well. You can do similar things with people in domestic settings. Deliver information in a currency that makes sense to them. And this is just an example of how you extrapolate that idea, and you can have a coffee shop where you can deliver instant information via mobile devices to the staff who are operating the machinery in the coffee shop. So send targeted messages to show how you're currently performing against your colleagues in the shops around the corner, and use that to incentivize staff to maintain their good behaviour or to change their behaviour. And of course, if you link that to some sort of monetary incentive whereby you're looking at potentially making a bonus if you're the best performing shop this month, then those become additional tools that can be used by organisations and could be used by households as well, to help incentivise people to maintain good behaviour. This is the same image that I had earlier on. A similar one could be just a simple message to your phone as you're sitting on the TV watching telly. You've left the lights on upstairs, would you like to switch them off? You press the green button, yes, and it's done for you. Closing the loop, making it easy for end users, that provides real value to them and they're likely to engage. This is just to finish off. We will be able to deliver more effective targeted communications to customers. We're going to be able to build personalised value through products and services. At the moment, it's often treated as a kind of one-way communication that utilities or other organisations can provide tools and services to end users. But I think there's a great opportunity to better engage with customers and consumers by involving them in the creation and innovation process. And some large organisations are beginning to do that successfully. Energy suppliers can further build trust and engagement through openness and essentially inviting their consumers to work with them in finding the best solutions. That's the end of my slides. I hope that's been interesting. I'll hand back over to Elena to finish off.
Okay, thank you very much, John and Ken, on your talk. And as you can see, we will go into the question answer session now. We have about 25 minutes to do so, trying to finish by 2 o'clock, but feel free to ask your questions. As you can see on the question side, Kickstart Online, Craig already did the courtesy of finding the link to Fun Theory, which you can watch at YouTube, on YouTube, or just use YouTube and type Fun Theory. You can have a look at it. So to see another illustration to what we're talking about today. There are a few questions already which I start asking, and please feel free to type your own question. If you want to ask anything, the guys will stay here, or just contact us separately after the webinar if you feel it's more comfortable for you. So the first question I've got here, which relates to your website, which you're saying that you have a G-committer and which streams all the data to the internal monitor and also to the website. So the question is, the website is free, and for how long it will remain free before the charges can actually be applied for that?
Yeah, I mean, it's a good question. We at the moment we have both domestic and non-domestic customers using our web service. Currently, we don't charge domestic consumers for it. What's probably likely to happen is that because we are a very small company, it's most likely that that our products and services will eventually be delivered to end users, and this is on behalf of other companies that are similar to ourselves, other display manufacturers, etc. It's most likely that these types of products and services will be delivered through utility companies, and so at that point I would be surprised if utility companies don't try to recoup their money in some fashion. But it may be that there's that these services are delivered by utilities in return for increased loyalty from their customers, for example. It's very difficult to know exactly how that might work, but yes, you would expect that if we're delivering much higher value services to end users, then there would be some fee for it.
Okay, thank you very much. And next question, actually the next two questions are kind of touching different aspects of the same. One is, how intelligent are these devices, and can they detect which appliances consume the highest energy and feed this information back to the customer?
So the products that we used in the study with Napier University.
Yes, it was a whole house system. It was essentially connected to at the point of entry into the home. So we had an electricity consumption meter and gas consumption meter, but Ken has a different system now. The system has moved on quite dramatically since we last used it for that trial. Take on, Ken.
So at the time, yeah, I mean, when we did that trial, our devices were not able to detect individual appliances through, you might be referring to frequency signatures or something, and our first generation product doesn't do that. However, what we did have, and what users made use of in that trial and continue to make use of, is that we have a very simple mechanism for and we call it our individual appliance monitoring mechanism, whereby you press a button on the display and it effectively zeroes the load that is currently in the house, in order that when you then switch on a new appliance, it will tell you how much that individual appliance uses. So it's you could say it's a relatively crude mechanism. However, it's a very, very effective mechanism, particularly in domestic homes, where people just want that. They want to get a quick feel for how much does my washing machine use, how much does my kettle use, and often in domestic settings, although we are all very au fait with how much various different things use, a lot of people don't understand even the very simple difference between a kettle and a strip light, for example. So that kind of simple feedback, press a button, switch something on, 2.6 kilowatts is what my kettle uses. Great, it's very effective. As we move forward, yes, our new devices will be able to do that in much more detail.
What I would say here is the first generation of Ujica that we were using did have a function where essentially you could pause. The energy monitor was monitoring Ujica was monitoring the energy consumption baseline for the entire home, and there was a button within the display which paused the background, as we call it, background energy consumption, and the next appliance that was turned on then was being shown in colour and also in quantifiable by cost and kilowatt hour on the display. So it could almost be employed as an energy auditing facility, but it wasn't used that extensively by the occupants because they were just looking for this, as Ken said, holistic view of how the home was being used. That sort of level of engagement with the energy monitor was used at the early on stage by a number of occupants, but not right across the board. And to have that level of information is going into the multiple platform where you start to use it on different displays and have it where you want it. So not this trial, but the technology is there.
Yeah.
Okay, next question again regarding how the monitor is used. So can the smart meter be used incorrectly, and will it have an effect to the energy use? Do you have any examples or any stories about...
Can smart meters be used incorrectly?
Incorrectly, yeah.
Right, so the first thing is that the product that we used in this trial is not a smart meter. Right? Yeah. So a smart meter has a particular description. Our product is an energy display device. So you may be asking, just could our type of device be used incorrectly? I guess the question maybe is, could it be misunderstood? I haven't had any reports of people misunderstanding it. Generally, no. People understand it very, very well, and I haven't had any reports of people, understanding the opposite message. You could maybe that's what you're referring to. I guess the key thing is just to go back to when you're designing products like this, is to make sure that you observe and understand the end users who are going to be using it, in order that you design it in such a way that you try to ensure that people will always understand it and engage with it. So I haven't had any experience of our product being misunderstood or leading to the opposite understanding. With smart meters, if that's what you're asking about, I don't think so. A smart meter system will be a very secure system in someone's home. It's extremely unlikely that anyone could tamper with it, or that it could be used incorrectly. Virtually impossible, I would say.
Yeah, what I would say is there's a number of studies and trials done with more simplistic kind of black and white monochrome number display, electricity only energy monitors down south, and a lot of the conclusions on that particular piece of work started to comment on the from shelf to cupboard lifestyle or lifetime.
We used to use the term mean time to kitchen drawer.
That's what it is, mean time to kitchen drawer, or shelf to kitchen drawer.
About 2 or 3 weeks.
That's exactly what it is, and that's when it was being misunderstood, or that's when it's being probably used incorrectly, where it doesn't hold the level of engagement, and it's shipped off. And you'll notice that some of the research that coming out of the University of East Anglia or Oxford, their model is they've kind of commented recently on the energy monitor is first of all interesting, and then ignored, and then annoying, and then scrapped. But that was usually seen within a fairly short space of time. We didn't witness that here, and it probably becomes because we're using such almost a different animal compared to what one's being used before previously. Smart meters being used incorrectly, I would say, just confusing communication language. You can't start to interrupt late. between different pieces of appliances. Would you agree with that? If you have multiple different smart meters from different companies with different communication protocol, and it becomes more difficult then for certain pieces of kit to be harmonised in the home.
In theory, that's not going to be a problem.
No. Okay.
There's a lot of work going on behind the scenes at the moment to ensure that products that do go into people's homes are easy to use, easy to install, reliable, etc., etc. So when the smart meter rollout happens, that's what people will get.
Okay, now it's at least two questions from two different attendees about what is the cost of one-off domestic system and what is the running cost of ongoing cost of the thing. But I want to add to this question a little bit more from myself. The question would be, because you mentioned when you did your presentation, you mentioned that the systems were installed in the new built houses. So could it be retrofitted in the existing house, and what would be the cost of one-off system and what would be the cost of ongoing running of such system in the house? That would be the question.
Okay, well, just before Ken jumps in, I just want to say that we have in our project successfully retrofitted, well, Ken's team has, for projects that we're looking at on doing energy audits of historically built properties with Historic Scotland. So these are properties, tenant buildings in Edinburgh, cottages in Newton Grange, and pre 1850 age properties in Newtown, Old Town of Edinburgh, and they went in fairly simple. There was a bit of issue with the gas meter being swapped out, but that's never really usually a problem. We'll move on to Ken, let him finish that.
So we've got a range of different types of systems, from the most simple is monitoring only electricity on one channel, through to more complex where we might be monitoring multiple channels from a variety of different types of sources. So it's difficult to give you a fixed price for a typical system. And also we don't sell directly to domestic consumers, so we as a business sell through channels. Most of the products of ours which go into domestic homes arrive there via partners who are working in the new build home sector. So most of our products which are in domestic homes at the moment are going into new houses. I won't go into the detail of why that makes most sense to us as a business, but our product is, I guess, relatively expensive if you are a one-off domestic consumer. Right now, our Generation 1 product is not something that would do very well if we tried to sell it in John Lewis, because we need to sell it for, £300 or so. But that isn't our model. It's very effective when it goes into new build homes, and the consumer doesn't actually have to pay for it either. So that's a great mechanism for delivering it to consumers. Our next generation products will cost less, and clearly volumes has a big part to play. So if somebody wanted to buy 10,000 units from us, then the price is different from what it would be if it was one. I'm not sure if that answers the question. The other question about retrofitting, yes, we frequently retrofit our systems into all sorts of shapes and sizes of buildings. We do face problems and challenges in some older buildings where you've maybe got kind of 2 or 3 feet thick sandstone walls, or in some modern buildings where you've got all sorts of metal cladding, etc. All of those things act as obstacles for the wireless signal between our transmitter and our display. So that can pose us challenges. However, having said that, we've successfully installed it in some very challenging environments.
Yeah, there is another question here, also related to retrofit, I believe. Does this device qualify for eligible technology for Green Deal, for example, or for Eco?
Unfortunately, it doesn't qualify for Green Deal at the moment, which is, I think, pretty unfortunate, both for us as an industry and for consumers, because because I think it offers a real, a real opportunity for them to help save energy. We are part of a group called CDIG, which means Consumer Energy Displays Industry Group, and we as a group are talking to government about how we can have devices and equipment like this included in Green Deal. So it may be something that comes online in the future, but at the moment we're not eligible.
Yeah, worth mentioning possibly is that the Energy Monitor does get points in the Code of Sustainable Homes.
Yeah, absolutely, yeah.
It also features heavily in the, I think it's aspect 5 of Section 7, silver and gold, and you need to monitor the heat consumption to get gold.
Yeah.
So that's
that's actually one of the main reasons that our product goes into new build homes.
Satisfies
is because if you are a new home builder, you're looking at how you can satisfy the conditions for the Code of Sustainable Homes
and Section 7 sustainability,
and Section 7 in Scotland. And one of the best ways to do that is to get 2 credits for an energy display device. And you get 1 credit for electricity and 1 for your primary heating source.
Yeah.
Okay. Next question is quite technical. I will read it, but if you're struggling to answer that, please let me know and we will ask the person who asked to rephrase it. Has RH and ACR been recorded in the trials, and could the control of RH result in reduction of high temperature set by users over the default anticipated? So for example, if you use wool insulation in the wall, it can save 2 degrees on necessary room temperature. So the reason why I'm saying it's a bit, the reason why I'm saying a bit technical, because I don't know what RH and ACR stand for. But
RH is relative humidity.
Yeah, thank you.
I'm not sure what ACR is actually.
Air conditioner. Just to try and start to cover that, and maybe we might stray into an answer accidentally, is the temperature profile of the occupants' homes were monitored across the trial. There was a temperature probe monitor. Temperature probe inside the monitor. So we're able to see the temperature profile across the occupants, and that didn't vary significantly between those who had it and didn't have. Coming on to, I think it's maybe what I didn't mention in the presentation, which might be important to try and contextualise it in people's minds. The pathology, the building pathology, the houses are all timber framed, lightweight construction, built SAP 2005, constructed in 2010, and pretty much U values and the building heat loss parameters were very, very similar, if not identical. So the gas consumption has actually been normalised against what the house should have been using as far as SAP is concerned. So that takes into consideration degree days, metabolic rate, heat gain, solar heat gain, fabric heat loss, ventilation heat loss. So that was the parameters by which we got the savings on the energy, on the gas energy for the heating, and the water heating as well for the boiler system. The air change rate? Yeah, SAP includes that, and the relative humidity wasn't measured. No, it wasn't part of the study. So say to that.
Okay, another question from the same person, actually from John Pryle. It is a way forward, but to move forward domestic buildings having whole house ventilation and inline heating system, whose primitive differences between the non-domestic system frustrate efficient temperature reduction in the rooms not in use due to the inability to isolate must be overcome, and could your control and current telemetry enable this? So phrasing it a different way, so how your control and your system could enable the issues with different rooms.
Air handling units, moving air around. Okay, yeah. Well, I think Ken's better placed to answer that, but certainly the work that we hope to engage with again as far as smarter homes are concerned is to have that element of and it kind of comes back to this utopian future where we're not living in homes anymore, they're machines to live in, and we do have significant control where we want it, or we can relinquish certain control where we don't want it, where the house is making decisions to create an optimal living environment. I'm not sure if Ken, you have anything to add.
Well, I mean, I think one of the things that I get from the question there is that although we're looking at installing efficient, building fabric technologies, etc., we still have the issue that you can have 4 rooms in a house which are unoccupied, and yet they're sitting there pumping out heat, and nobody knows about it. So yes, our system that's under development does have mechanisms in there which will enable us to connect with PIR sensors, for example. Relative humidity and CO2 can also be used to gauge as to whether there are any occupants within a space. We can use that information to feed back to the consumer in the house and say, listen, we're pretty sure that there's 4 rooms upstairs that have got nobody in them, and there's nobody been in them for the last half an hour, but the temperature is still 23 degrees up there. Would you like to do something about it? So the answer is yes. So with better sensor technology and feedback mechanisms, we can address that problem.
Okay. There's another question here. So far it's the last question in my list, and it looks like we're coming towards 2 o'clock, so probably it's going to be the last question unless somebody else came up. There's another question, but anyway. There's a question from Property Logbook Company Limited, who are saying that they are running the largest water and energy efficiency project within residential homes in Scotland, and they're asking about your trial at the residential homes. Of those 52 homes, how statistically reliable they were, and what did you put on a baseline, and how long did you run this to get that baseline? So what actually you put on a baseline of the project to compare against the achievements of the project?
Well, certainly to create some sort of statistical significance, we did monitor, or we did ask the questions based on people's attitudes towards energy before and at the end, and then that was a statistically significant t-test based on that, with a confidence interval of 95%, which is common percentage for social science projects. That's what we done on that. And the other part of that was baseline. How long? Sure, I'm going to get this baseline.
Tell us a bit how did you select those properties, and what were the occupants? How representative those were for the residentials in Scotland?
I mentioned before to group the occupants in the different rows with the energy model without. We worked with the housing associations who were allocating the occupants to those homes, and the homes were occupied for most were occupied for about 4 or 5 months before we actually commenced the trial. So I think that's probably the answer. I must have misunderstood that. And the occupants that were being categorised for each of these homes, the housing officers, we broke them down into groups of family sizes and kind of profiling of lifestyle patterns and employment status, etc., and age, and that was created our 2 groups. And like I said, then the houses were being monitored for a couple of months while they're in place before the trial started.
Okay. The last question which I'm going to ask, it kind of wraps up the presentation. Are there any published information on this work which you have done? Any conferences, proceedings, journals?
Well, we published through the LCBTG website, which is a series of results that ultimately went towards the TSB final report. That's on that website. We are keen to go back, because we know it's only 6 months of data. We're keen to go back. It's now been 18 months to actually see what's happened further, and then we're going to publish this through a series of journals, and that's the publishing strategy just now. But currently the report is on the LCBTG website.
Another comment came through, so I can't stop reading them, so I will go ahead with it anyway. So what kind of technology you're planning is required to enable this option of providing feedback and asking about switching things off? Is there any technology behind it? Can you tell us about
Well, yeah, there is obviously quite a lot of technology required in order to enable that, and that's what I said in one of the slides, is that you need to have sensors to be able to pick up the fact that the lights have been left on. You need to be able to send that information back to a central location where that data can be processed. So in our case, it's up to a web application. You then need to turn that into meaningful messages that can be sent back to the user in the home, and again, that's using communication from the web service back down to the end user, and then the end user needs to have some form of technology available that will receive that information and deliver it to him. So if it's a smartphone or some other sort of mobile device with an engaging user interface. So there's a lot of technology that needs to be in place in order to make that happen. But it's by no means, all of that technology actually exists today. It's just a case of putting it together in such a way that makes sense to domestic houses, and it's the same for heating.
Okay. There is last comment from John Fial. Thank you very much.
Sorry, I should just mention, of course, you then have to have the user then says, yes, I do want to switch off the lights. You then have to have the message going back to the web and being sent back to the piece of control equipment in the home. So all of that has to happen, but the technology is available.
Yeah. Okay. There is a last comment from John Fial, who we want to thank for live participation. He's commenting on the fact that TSB monitoring has no baseline and should not be carried out within the first year or two of post-construction, but it's widely accepted. However, I think John already mentioned that we are going back to the same properties with another leg of this project exactly for this purpose, that we don't really trust, or we don't really baseline on the first year of occupation. We want to come back and re-monitor it after a certain time. So thanks for commenting it. Do you want to add anything, John, to this?
No, just that on the side-by-side comparative. It's because we had people with and without, so therefore essentially they were using the homes in the same format.
Okay, I would like to thank everybody here and everybody who attended the webinar through Kickstart Online service, and I would like to thank Kickstart Online as well for providing us this option of doing this webinar. And the last out of 3 webinars with LCBT Gateway going to be live tomorrow, and that would be based on acoustic project. Thank you very much, and goodbye.